My name is Safari Ernest. Today we are going to look at measures of variation and the statistics. And so with measures of variation, we are going to look at how far is the mean deviated from each tendency. Okay, and so we have four things to talk about when we are dealing with measures of variation. The first one is range. The second one is mean deviation. The third is standard deviation. And the fourth one is variance. So these are the four things that we are going to look at, but we will look at on group data for range, on group data for mean deviation, on group data for standard deviation, and on group data for variance. So this is what we are going to do. Right after looking at it on group data, you will also look at the group data for the four. Okay, so now you ask yourself, when we talk about range, what do we mean? Range means what? The distance or the gap between two what points. And so here we are talking about the interval, and from the interval we need what? The lower limit or the lower point or the lower value, right? And what? The highest value or the highest point. That is when we talk about range. And when we talk about mean deviation, here we are also interested in how far is the mean deviated from the central tendency. Okay, sorry, from the x values, right? Yes, and standard deviation too. We are also interested in deviation. The three of them, they are all deviations, right? Okay, so without wasting much time, let's quickly rush to range and look at what range is. Okay, so range. Now, I said range is what? The gap or the interval, the distance between what? Two given points, right? And before you identify the distance or the gap, you need what? The lower limit or the lower value. And you also need the highest value or the highest what? Point. And so here, let's say a data is given. A data is given 2, 5, 1, 7, right? And you are being asked to calculate for range for this data set. Now I said range is what? Range is always your highest value minus what? The lowest value. This is the formula for range, right? So you look through the data sets. Now which one is the highest? You will see we have what? 7, right? And so we have 7 here minus the lowest is what? 1. Okay, so 7 minus 1 is what? 6. So we have 6 here. So it means the range for this data set is what? 6. Also, another example, if you have, let's say, if you have 10, 8, 4, 7, 9, and you are being asked to calculate for what? The range. You know the range, as I said, you always need what? The highest and the lowest. You are trying to find the gap between them, right? So here the highest is what? 10, right? Minus, which one is the lowest? That is 4. So 10 minus 4. And 10 minus 4 is what? 6, right? So this is the range, right? So this is the range for an ungroup data. For range, we are not going to talk about any group data for range. Okay, so this is range. We are done with it. Let's also look at what again? Let's also look at the mean deviation of an ungroup data, right? Let's also look at mean deviation of an ungroup data. Okay, so mean deviation, mean deviation, mean deviation, right? So for mean deviation, standard deviation, variance, all that we are going to do from the formula, you see x minus x bar. You see this either in absolute value or in brackets, right? So anytime you see it in brackets, it means there is square. Without the brackets, there is what? Absolute value. It's still the same because they will all end up giving you a positive answer, right? Okay, so this is deviation. When we say deviation, this is what we mean by deviation. Deviation, right? So in all the formulas for mean, standard deviation, and variance, you'll be seeing this two things, x minus x bar, because standard deviation, variance is also deviation, and mean deviation is also what, a deviation, right? But this one we are saying mean deviation because we want to deviate the mean from what, the x values, right? Okay, so let's look at the formula for mean deviation, and also we take an example. Now the formula is summation. We are looking at the ungrouped data, right? Ungrouped data, and so it's summation x minus x bar all over n, right? So this x bar is what, mean, and this x, they are the values that is given in the question, right? And n refers to the number or the frequency. So when you count the number, the total number that you have is what, the n, and this one represents what, summation. So for example, if you have 2, 6, and let's say 1, 1, yeah, let me use this one. If you have 2, 6, 1, okay, let me add, it's okay, sure. So if you have this example, it's very simple. Now this is x value, x value, x value, x value. So the x that you see here, each of this is what, x, right? Now I told you in the previous video that whenever you are given a formula, right, what you do first is you start from the right to left, right? So starting from right, the first thing that we see here is what, mean. So it means the formula wants, or the formula needs us to calculate for what, mean. I hope you get it. So now we calculate mean of this data set. Now we say mean is equal to summation x, because we are going to add all the x values and divide it by n, right? So we add this 2 plus 6 plus 1 plus 1, then 1 2 3 4, so we divide it by 4. Okay, so 2 plus 6 is what, 8, plus 1 is 9, plus 1 is what, 10. So we have 10 over 4, right? Which is also 2.5, which is also 2.5. Yes, so there is it. So it means the mean is what, 2.5. So you can say, therefore the mean is what, or the x bar is what, 2.5. So since you have the x bar, look here, you have the x bar, right? And you are supposed to deviate the mean from each value of x, and these are the x values. So you have to subtract the mean from each value. When you finish, you add them and you divide it by what, 1 2 3 4. That is all. So we are done with calculating for what, the mean. Now the next one is, from this one we come to this side, that is x minus mean, right? So the first one is what, 2. So we put it in absolute value, 2 minus 2.5, and we also say plus 6 minus 2.5 plus 1 minus 2.5, right? Then we can also say plus 1 minus 2.5. So these are the 4 things we have, 1 2 3 4, right? 1 2 3 4. So we have deviated the mean. I hope you get it. So now let's calculate for the first one. 2 minus 2.5 will give you what? It will give us 0.5. To give us 0.5. It is absolute. You are going to get negative 0.5, right? But negative 0.5, because it is absolute value, it means you are supposed to clear the negative and write the positive answer. So negative 0.5, the absolute value of negative 0.5 is what? 0.5. So here you write 0.5 plus, you find here too, 6 minus 2.5 is what? 3.5. is 3.5 plus 1 minus 2.5 is also 1.5. It is negative, but we are taking the absolute. Okay, then plus this one too is the same, 1.5. Okay, yes. So since we are done, we are saying we are done with this one, which is here. We are done with the deviation, which is also here. They are saying what, summation. It means we have to sum everything, right, and divide it by what, 1 2 3 4. So we are going to sum everything and divide this by 1 2 3 4. So by 4. I hope you get it. Yes. So this plus this will give you what? 4. And this plus this will give you 5.5. And this plus this will give you what? 7. Right? Yes. So we are getting 7 over 4, which is equal to 1.75. Okay. So 1.75 here is what? Our mean deviation. 1.75. Okay, so that is what mean deviation. For mean deviation of an ungroup data, it's very simple. You just have to put the formula in mind that always we have something we call deviation, and deviation is what? X minus mean, right? And so x minus mean is a deviation, and you sum the deviation, you divide it by the frequency. So an example like this, you add everything, you divide it by the number to find for what? Your mean, right? So if you have the mean, now you deviate the mean, x minus mean. So you take one number, you subtract the mean, you take another number, you subtract the mean from it, the same. That is what we have here. Then when you finish the deviation, they are saying summation, right? So you have to add everything, then you divide it by n, which is 1 2 3 4. That is what you see here to arrive at the mean deviation. So this is the a question under mean deviation, and this is how we solve the mean deviation. Okay, so now we are going to look at how to also calculate variance under mean deviation. How to also calculate variance under mean deviation. Okay, so it's very simple. Variance on group data. Okay, so for variance of an ungroup data, it's also simple. Because I said variance is also a deviation, we are going to use the same formula, but we are going to add something small to the formula to get what? The deviation that we want. I hope you get it. And so for the deviation that we want, already we realize the formula for mean deviation is what? The summation. Let me just write here so that I get more space. Summation what? X minus x bar all over what? N. Now nothing has changed here. This is what? Mean deviation. So if you want to get variance, the mean deviation formula, you just put a square here. Do you get it? To get what? Variance. So if you know the formula for mean deviation, that is all. You know the formula for variance and standard deviation, because you just put a square here and that is all. Okay, so now we are going to do what we did. We are going to take a question and we also look at it, but this time around, after deviating it, we have to square it. I hope you get it. Okay, so example, if you have 2 5 6, now 2 5 6, how do you even calculate for the variance of 2 5 6? It's very simple. This one too, they are all values for what? X, right? They are values of x. So what you do is, here you calculate for what? Mean, and after getting the mean, you deviate the mean from it. That will be it, right? Then after deviating each, you square everything before you sum it. Do you get it? So now let's calculate for the mean first. So should I say solution? We have mean, which is x bar, is equal to summation x over n. So the summation x is what? 2 plus 5 plus 6 divided by 1 2 3, right? So here you have what? This is 7, this is 6, right? So 13 divided by 3 is what? So you have 13 divided by 3, and this one is giving you what? To give you 4 points, I think it's what? 13 divided by 3 is giving us 4.33. So we have 4.33. So this is what? Our mean. This is our mean. Now we know the mean, right? So we are going to do same. We are going to deviate it, right? We are going to deviate it. After deviating it, then we square everything. So the first one is what? 2. So we deviate the 2. 2 minus 4.33 then we square it because there is square here. So this is the first deviation. I hope you get it. Then plus, because they are saying sum, we have to add. So plus another value is what? Another x value is what? 5. So we say 5 minus 4.33, and this one to square it. I hope you are following. Then the next one is what? 6. So plus 6 minus 4.33. This one to square it. And so after deviating everything and squaring it, you divide it by the n. The n is what? 1, 2, 3. So we have 3 numbers. So we are almost there. Here, you solve for this, you write your answer. You solve for this, you write your answer. You solve for this, you write your answer. And you divide it by 3. So let's do that simple calculation. We have 2 minus 4.33 squared, right? So for this, we have 5.429. So let's say 5.429 to 3 decimal places. Okay, they gave us 4 decimal places, so let's use that one instead. So it's what? 8, 9, right? You can only round it off after your calculation, right? So when you are doing the calculation, you don't round it. Okay, plus, then we have 5 minus 4.33 squared, right? And this one is also giving us 0.4489 plus, we do same for 6, right? And this one is giving us 2.7889. Then we divide everything here by 3. So we are going to sum this and divide it by 3. So let's sum it. We have 5.4289 plus 0.4489 plus 2.7889. And so this alone, we have 8.6667 divided by 3. And so this one, we divide it by 3. What are we getting? We have 2.8889. So if, let's say, the question asks you to round it to 2 decimal places, then you can say your variance is approximately what? 2.89. Then you end there. So this is how to calculate for what? Variance of unknown group data. Do you get it? Some of the steps you may choose to skip, especially this one, because after getting the mean and you deviate it, you can put everything here together on the calculator to get your answer, and you divide it by 3 here, right? So that you skip here. But for more understanding and more details, that is why I brought this, right? So maybe in your calculations you can just skip this one, and after getting here, I said to you, you make sure you write all the decimals, right? You can only round it off when you get to what? The final answer, because when you round it off here, it will affect what? The answer. I hope you get it. It is going to reduce the number, right? Yes. So this is how you calculate for variance. You use the same formula. You calculate for mean, you deviate it just like the mean deviation, right? But for variance, you square it. I hope you get it. Yes. And after getting the variance, that is all. So one thing you have to notice, after getting the variance, when you square root the variance, you get standard deviation, right? So if we are to calculate for standard deviation after this question, after we have gotten our variance to be 2.89, we can just square root, then we find for our standard deviation, which is 2.89. So we are getting 1.7 as our standard deviation. Yes, which is very true. So you may choose not to even work out for the standard deviation at all, because anytime you put a square root under the variance, you get what? Standard deviation. Okay, so let's also look at standard deviation of unknown group data, how to also solve that. Okay, so here, okay, sure. So I'm not supposed to even clean it, because we are going to use the same question and the same procedures, but I'm going to teach you what will change, right? So here we had what 13 over 3 getting 4.333, and we said our mean is equal to what 4.33. Okay, the same question using what standard solving for what standard deviation, right? The same question for standard deviation. Okay, so after getting the mean, this one too you deviate it, but for standard deviation this formula is for variance, right? The only thing that will change under standard deviation is this whole formula is going to be under a square root. This is standard deviation. So look at the relationship. Initially it was what mean deviation, then we brought a square here to become variance. Now square root, it has become a standard deviation. So you see they follow. I hope you get it. So it means if we are square rooting this side, it means okay, for mean here is okay. After getting to this side, we are this thing that you see under the square root is what you see here, right? So we are going to square root this because we are looking for standard deviation. We square root this. Right, so let me change the marker. We are going to square root this. Do you get it? And square root this, we are going to square root everything because we are dealing with a standard deviation. You square root it, you come here, you square root it, the same thing. Your final answer too, you square root it. And so when you square root this one, now you are getting what? Your standard deviation. Now you are getting what? Your standard deviation. So standard deviation and variance, they are okay. So let us square root 2.889, and we have 1.6996. 1.6996. Okay, so if they ask you to run it to two decimal place, if they ask you to run this to two decimal place, you see we have to two decimal place. If you add 1 to this one, you are going to get 70, right? That is the same as 1.7 or 1.70. So for standard deviation and variance, it's just the same procedures. Just use the same procedures for calculating the mean, deviate it. But in this case, when you are dealing with standard deviation, you don't forget you put everything what under the square root. So here, if I am to calculate for variance, I have to remove the square root. If I remove the square root, I'll get what? My variance. So it's the same thing in an examination. If you solve a question and let's say you have the standard deviation of that question to be 1.70. If you have 1.70 and you want to calculate for variance, what you do is you just square that answer, right? You just square that answer. So if you square the answer, you are getting, if you square this, you are getting 2.8889. That is what you see here. That is what you see here. So it's the same. Whenever you square variance, you get what? Standard deviation. That is it. So you put this one in mind. Okay, then let's also look at another relationship we can also talk about. So have this thing in mind that always your variance is greater than the standard deviation. Always variance is greater than what? Your standard deviation. So put this thing in mind. So if you see the standard deviation is what? 1.70, but when you square it, you get what? 2.8889. And so this is what? Variance. So always variance is greater than what? Standard deviation. There is no way your standard deviation will be greater than what? Your variance. Okay, so here we are done with calculating for the range, mean deviation, standard deviation, and variance of an ungrouped what? Data. So now we have a table or a question here. So we are going to use this table to look at how to calculate for measures of variation, that is group data for mean deviation, variance, and standard deviation. This is what we call group data because it has been grouped into what classes. The first one that we did, you could see it was just raw data which was given. So now we are going to look at how to use this table to calculate for mean deviation, standard deviation, and variance. Okay, so now let's go. Now before then, let's look at the formula. We are saying for the formula mean deviation, for the formula for mean deviation, we are going to square the mean deviation formula to get what? Standard deviation. After calculating the standard deviation, after calculating for variance, we square root the variance to get what? Standard deviation, right? So let's look for the formula for the group data. The one that we did is on group data, but this one too is very simple, just like the previous one. So for mean deviation, it's still the same, summation x minus x bar, right, over n. This is for the on group data, right? Now because this is a group data, you see now we have introduced what? Frequency, what we call f, right? So anytime you have a group data, you don't forget you introduce what? F in the formula, right? So the f will come here, right? And this n is the same as the total frequency, right? So normally when you say n, you are referring to 1 2 3 4, right? But when you say summation of f, you are referring to this plus this plus this plus this. That is what will come here. I hope you get it. Yes. So now for f, we have now introduced f here. So don't forget this summation f that you see over here, you bring it down here. That is all. So this is for what? Mean deviation. Then if you want the variance, it's the same thing for mean deviation, but we are going to square it. Summation f x minus x bar over summation f. So this is the same as this, right? But you just square it like this to become what? Variance, right? Then when you are looking for the standard deviation is the same formula. Summation f x minus x bar, you square this one, summation f. So it's the same as the variance, right? But you just bring a square root, right? So always put it in mind. Standard deviation is just like the variance, but under a square root, right? And variance is just like the mean deviation, but rather what? Squared. So this is the formula that we are going to use to calculate for what we have here. Okay, so just put the formula in mind. Okay, so let me clean the board so that I'll get a space for what we are about to do. Okay, so now we have the class limit and the frequency. So we are dealing with mean deviation first. So let's look at mean deviation. So for mean deviation, we know we are going to need what? The mean, right? So we first calculate for mean. Because they are all deviations, we will need mean. Mean is what? Summation fx. No, I'll need a space here, so let me extend it to the other side. Okay, so we all know mean is equal to what? Summation of fx over summation f, right? So we have f here, right? But we don't have x, right? And you know from classification of data that x is what? The midpoint, right? So here you have to establish another column called what? Midpoint, which is also known as the x, right? Okay, so for x, we know the midpoint is, you just add these two and you divide it by what? 2, right? So 1 plus 10 is what? 11. Then you divide it by 2 to get 5.5. Okay, then you do same for the next one. This one will give what? 31. Then 31, when you divide it by 2, you get what? 15.5. And so I always say in an examination, for you to save time, you find the difference between the two. So what is the difference between the two? It's 10, right? So now you add 10, right? So when you add 10 to 15.5, you get what? 25.5, right? Then this one, you add 10 to it to get what? 35.5. Instead of adding and dividing each class, right? So these are the midpoints that we have. But from the formula, we are saying we have x. So after getting your x, we are starting from the right. So after getting your x, you multiply the x by what? F, right? So we have to multiply this x by this f, this x by this f. So now we create a column called fx. right? We create a column called fx, and so this fx will be this times this, right? So 3 times 5.5 is what? 3 times 5.5 is 16.5. Is 16.5. 16.5, right? The next one is 6 times 15.5 is 93. The next one is 7 times 25.5 is 178.5. And the next one is 4 times 35.5, 142. Right? So now we are done with the fx that you see here. We are done. But this is what summation. It means we have to sum the fx. So this fx that we are having on the table, we are going to sum it according to what the formula. So we sum it and we name it summation of fx. And so for the summation of fx, we are going to add everything here. The first one is 16.5 plus 93 plus 178.5 plus 142, which is 430. And so we have the summation. This 430. So we are done with the first part, right? We are left with the second part, which is summation of f. So summation of f, we are still calculating for mean. Don't forget, we haven't yet started the question. We are calculating for the mean. Okay, so 430, we sum this one to get summation of f. So summation of f is equal to this plus this is what? 9 plus this is 16 plus this is 20. So we have 20. So now to find the mean or the x bar, it is 430 over 20. 430 over what? 20. And here we are getting what? 21.1. Right? 430 over 20. 21.5. 21.5. So the mean is what? 21.5. The mean is 21.5. Okay, so now we start with the question because we are going to look at mean deviation, and we know for mean deviation it is what? So now we know our mean. So let me just write it somewhere here so that we don't forget. Our mean is what? 21.5. Okay, so we are going to look at the mean deviation. We are going to look at the mean deviation. So for mean deviation, we write our formula mean deviation, right? And for mean deviation, you know the formula already, which is summation of f multiplying the deviation, then you divide it by what? Summation f again. So your summation of f multiplying your deviation, then you divide it by this one, the summation f again. Okay, so now we are starting from the right. It means you have to find for the deviation, right? So let me just clean this one. We have to find for x minus x bar. So we say x minus x bar. That is the deviation, right? So we are going to find the deviation. So these are the values of x, right? So we are going to subtract the mean from each of them. You get it, to get our deviation. So we know our mean is 21.5 and the first x is 5.5. So we are going to subtract this from this to get our first deviation. Okay, so that is 5.5 minus 21.5. That is what? 16. This is what? Absolute value, right? So we have to clear the negative and we write what? 16. And the next one is what? 15.5 minus 21.5. That is 6 instead of negative 6. Then we go again. 25.5 minus 21.5. We have 4 straight. Then 35.5 minus 21.5. We have 14. Right? So now we are done with the deviation. And after the deviation, what do you see here? F. So we have f, which is multiplying the deviation, right? So it means we say f multiplying. That is why I said start from the right. So we started by calculating mean, followed by finding what the deviation, right? Followed by what f multiplying the deviation, followed by f multiplying what the deviation. So now you have your f, and this f is supposed to multiply the deviation, right? Looking at the formula. Okay, so 3 times 16, that will be the first deviation, first f times deviation. So 16 multiplying 3 is what, 48. So we have 48 here. The next one is this 6 multiplying 6, giving us 36. 7 multiplying this, giving us what, 28. We have 4 multiplying 14, 56, right? 56. 56. Okay, so now we are done with what, the multiplication of f and what, the deviation, and this is what, sum. It means we have to sum this. So we have to sum this. Now when you sum it, you have to call it summation f x minus x bar. So that is what you see up there, right? You are summing this, so you have to write it this way. So we are going to sum this. So we have 48 plus 36 plus 28 plus what, 56. So that is 168. 168. 168. So we have the top here as 168. What do we do next? We need what, summation f, and summation f is already here, right? So we are going to divide this by this. I hope you get it. So our mean deviation now is equal to summation of this, which is 168, divided by 20, right? That will be our mean deviation. So our mean deviation is 8.4. It's 8.4. So please, we are done with the mean deviation. We started from here calculating midpoint. So always, if you write down the formula, you have to make sure that you always start from what, the right towards your left, right? So when you start, you see you get the entries what's correct. Other than that, when you put down the formula and you don't start from your right, you might forget what you even have to calculate for. I hope you get it. So when you start from your right, it will make the thing what, simple and easier for you to what, calculate everything that you want. Okay, so in this case, our mean deviation is what, 8.4. I hope you get it. Our mean deviation is 8.4. So now let's proceed by calculating what, the variance, right? Let's proceed by calculating the variance. Okay, so for variance, okay, so please, I'm cleaning the mean deviation. We know the mean deviation is what, 8.4. Let me write it somewhere so that, okay, we know the mean deviation is 8.4. Okay, so now we are going to calculate for the variance. Okay, we are going to calculate for the variance. Okay, so for variance, for variance for variance, we are saying it's just the same formula for mean deviation, but right now we are going to square the deviation, right? So summation f x minus x bar, but we square the deviation and we divide it by summation f. You get it? First, for mean deviation, we use this formula. Now we are squaring the deviation. So if you are squaring the deviation, now you have the deviation here, but it is not squared, right? So you have to square the deviation. X minus x bar. Sorry. X minus x bar. Then you square it, right? So that is how it works. So we are going to square what, this, we are going to square these numbers and put it there. Okay, so we have 16 squared, which is 256. We have 256. Okay, so now we have 6 squared, right? So we've squared this one to get this, we have to square this one too. So 6 squared is 36, right? So we have 36 here. Okay, we have another 36 here because 6 squared is what, 36. Then also we have 4 squared, which is what, 16, and we have 14 squared. 14 squared, 196. 196, right? Yes. And so we are done with the deviation squared, which is here. Now what is next? Our f multiplying the deviation squared. So we have to multiply f by this one, just like what we did for this one. We are going to multiply f by this deviation squared, right? Yes. So we say f multiplying deviation squared. Okay. Okay. So here we have our f here. So this f will multiply what? This deviation square. So 3 times 256 will give us 768. Okay. Then we have 6 times 36, which will also give us 216. 216. Then we have 7 multiplying 16, which is 112. Then we have 4 multiplying what? 196, which is 784. Okay, so now we are done with what? F multiplying the deviation square. I hope you get it. The next thing to do is what? We find the summation of this. So we are going to sum this and name it summation of f multiplying deviation squared. Right, and the answer is, so we sum everything here. That is 768 plus 216 plus 112 plus 784. Right, so we have 1880. We have 188 what? 0. So this is what we are going to divide by what? The summation f. So this over what? This. And so now we say our variance is equal to what? 1880 divided by 20. And so we can say our final answer is 94. Our final answer is what? 94. I hope you get it. So after getting your final answer as 94, now the next thing to do is what? We have to calculate for standard deviation, and you know already that standard deviation we are going to use the same formula, but we just bring a square root, right? So here you can just put a square root here, square root here, square root here, and you get what? Standard deviation. Better still, let's look at how to go by the standard deviation. So for standard deviation for standard deviation, we are going to use the same approach. You get it? But we just have to square root this. So we say square root of summation f multiplying deviation squared over summation of f, right? And the summation f deviation squared, we had 1880. So we say square root of 1880 over what? 20. This is it. So the one in the bracket is everything here, right? So this one, when you simplify it, what do you get? 94. So it means it is going to be square root of 94, and square root of 94 will give you what? So you see, that is why I said anytime you get the answer for variance, you just square root it to get what? Standard deviation. So square root of 94 will give you 9.65. So to 2 decimal place is 9.7. To 2 decimal place is 9.7. So our standard deviation is equal to 9.7. So our variance is what? 94, and standard deviation is what? 9.695. So 9.70. Okay, so this is the group data for measures of variation. This is how we go by. Just the formula, you start from your right hand side. The formula will tell you what to do. And so in this case, we are done with the group data. We are done with what do we call the group data as well. That is for mean deviation, variance, and what? Standard deviation. And this is what you see on the board. Okay, so please, you can go through it again, then you know how to calculate it. In our next video, we are going to look at how to calculate the measures of dispersion, that is the Chebyshev and empirical rule, skewness, coefficient of variation, and the rest. So this brings us to the end of this part.